Question number 201. Bending moment at any point is equal to the algebraic sum of option A all vertical forces, option B all horizontal forces, option C forces on either side of the point, option D moment of forces on either side of the point, option E is all of the above. Correct answer is D. It will be moment of forces on either side of the point. Question number 202. The rate of change of shearing force at any section is equal to the rate of option A loading at that section, option B change of deflection at that section, option C is a change of bending moment at that section, and option D is a integration of bending moment at that section, and option E is none of the above. Correct answer is A. It will be loading at that section. Question number 203. Two equal length beams are fixed at their ends. One carries a distributed load and other carries same load but concentrated in the middle. The ratio of maximum deflection will be option A is 2, option B is 3, option C is 4, option D is 6, and option E is 8. Correct answer is A. It will be 2. Question number 204. Two cantilever beams are of equal length. One carries a uniformly distributed load and other carries same load but concentrated at the free end. The ratio of maximum deflection is option A 5:6, option B 2:3, option C is 1:2, option D is 1:3, option E is 5:12. Correct answer is A. It will be 5:6. Question number 205. Two simply supported beams are of equal length. One carries a central load of W and other carries the uniformly distributed load such that total load is W. The ratio of maximum deflection in two cases is option A is 8:5, option B is 8:6, option C is 8:7, option D is 5:4, and option E is 2:1. Correct answer is A. It will be 8:5. Question number 206. The rate of change of bending moment at any section is equal to the option A shearing force at that section, option B rate of change of shearing force at that section, option C is deflection at that section, and option D is the rate of change of deflection at that section, and option E is the rate of loading at that section. Correct answer is A. It will be shearing force at that section. Question number 207. Figure A shows a beam supported at two ends with some overhanging portions and carrying uniformly distributed load. The bending moment diagram for it will be as shown in the figure B, C, D, or E. So in the figure A you can see a beam at two ends with some overhanging portion, okay, and option A there is showing the bending moment diagrams, option B and option C and option D and option E. So according to this option answer, option A will be B, option B will be C, option C is D, and option D is E, and option E is none of the above. So the correct answer is D. It will be it will be this one. This will be correct diagram. Question number 208. The moment diagram for a cantilever beam carrying uniformly distributed load will be: option A is a rectangle, option B is a triangle, option C is a parabola, option D is a cubic, option E is a elliptical. So correct answer is C, it will be parabola. Question number 209. The reaction in the case of hinged support: option A is acts perpendicular to beam, option B is perpendicular to surface of hinge, option C is along the surface of beam, and option D is opposite to the direction of load, and option E is in any direction depending upon the loads. So correct answer is E, it will be in any direction depending upon the loads. Question number 210. If the shear force is 0 along a section, the bending moment at that section will be: option A is minimum, option B is maximum, option C is 0, option D is could have any value, option E is either minimum or maximum. Correct answer is E, it will be either minimum or maximum. Question number 211. Zero bending moment in a fixed beam of length L carrying uniformly distributed load will occur at: option A L upon 2, option B L by 3, option C L upon 4, option D L upon 6, and option E is none of the above. Correct answer is A, it will be L by 2. Question number 212. If a beam is cut in halves horizontally and the two halves laid side by side, then the latter in comparison to the original beam will carry: option A same load, option B is a double load, option C is a half load, option D is a 1/4 load, option E is a 4 time load. Correct answer is C, it will be half load. Question number 213. The bulk modulus of material is defined as the ratio of: option A volume change to modulus of elasticity, option B stress intensity to volumetric strain, option C volume change to original volume, option D pressure applied to the change in volume, option E is a volumetric strain to the stress intensity. Correct answer is B, it will be stress intensity to volumetric strain. Question number 214. A beam is fixed at one end and freely supported at the other end. The load acts in the center. The maximum bending moment will occur at: option A under the load, option B fixed end, option C is supported end, option D is between center and fixed support, option E is between center and free end. Correct answer is B, it will be fixed end. Question number 215. The strength of a beam is directly proportional to its: option A is the length, option B is the depth, option C is the width, option D is the moment of inertia, option E is all of the above. Correct answer is C, it will be width. Question number 216. The strength of a beam is proportional to the square of its: option A is the length, option B is the depth, option C is the width, option D is the moment of inertia, option E is none of the above. Correct answer is B, it will be depth. Question number 217. Section modulus of a rectangular beam is equal to: option A is a width b into depth h square divided by 6. Option B, hb square upon 6. Option C is h square b square upon 6, and option D is a bh square upon 12, and option E is hb square upon 12. Correct answer is A. It will be width b into depth h square divided by 6. Question number 218. Section modulus of solid circular rod of diameter d is equal to, option A is d square by 10, option B is d cube by 10, option C is d power 4 by 10, option D d cube upon 20, and option E is d cube by 5. Correct answer is B. It will be d cube upon 10. Question number 219. Section modulus of a hollow circle with average diameter small d and wall thickness small t is equal to, option A 4 by 5 td square, option B 4 by 5 t square d square, option C 4 by 5 into dt square, and option D is 5 by 4 td square, and option E is 5 by 4 d square t. Correct answer is A. It will be 4 upon 5 or 4 by 5 d square. Question number 220. Moment of a beam is defined as its section modulus multiplied by, option A is a moment of inertia, option B is a stress, option C is a strain, and option D is a coefficient of elasticity, and option E is a half the depth. So correct answer is B. It will be stress. Question number 221. If a freely supported beam at its ends is loaded by a central concentrated load, then maximum moment is capital M if the same weight be equally distributed over the beam, then its maximum moment will be, option A is capital M, option B is M by 2, and option C is M by 3, and option D is M by 4, and option E is 2M. Correct answer is B. It will be M by 2. Question number 222. The point of contraflexure occur only in, option A is cantilever beams, option B is overhanging beams, and option C is simply supported beams, option D is continuous beams, and option E is uniform beams. Correct answer is B. It will be overhanging beams. Question number 223. Maximum shearing stress planes are inclined at the following angle to the principal plane. Option A is at 45 degree, option B is at 90 degree, option C is at 22.5 degree, and option D is depends on the magnitude of the loads, and option E is none of the above. Correct answer is A. It will be at 45 degree. Question number 224. The point of inflection or contraflexure is the point where, option A, bending moment diagram changes sign, option B, stress is minimum, option C is deflection change sign, option D, shear force and bending moment cross each other, option E is bending moment is maximum. Correct answer is A. Bending moment diagram change sign. Question number 225. The bending moment on a section is maximum where shearing force is, option A is maximum, option B is minimum, option C is equal, option D is changes sign, and option E is 0. Correct answer is E. It will be 0. Question number 226. In a fixed beam, carrying a central load in the middle, the bending moment will be 0 at a distance of option A. Length of beam L, option B is 0, option C is L by 2, option D is L by 4, option E is L by 3. Correct answer is D, it will be L by 4. Question number 227. Figure below shows a simply supported beam of length which carries a concentrated load W at C distance small a from support capital A and small b from support capital B. The maximum deflection occurs at point. So in the figure you can see a simply supported beam, point A, B and C, divided in two portions small a and b, loaded by W, and option A is A and option B is a C and option C is a B and option D is between A and C, option E is between C and B. Correct answer is E, it will be between C and B. So simply supported beam and the maximum deflection occur at between C and B, it means here somewhere. Question number 228. In above figure, the maximum deflection occurs at a following distance from B is option A is L by 3, option B is L square minus 2A square divided by 3, and option C is L square minus B square divided by 3, and option D is under root of L square minus A square divided by 3, and option E is under root of L square minus B square divided by 3. Correct answer is D, it will be under root of L square minus A square divided by 3. Question number 229. In the figure of problem 227, it means this one is the same, and he asking the deflection at C is or will be happen. Option A is WL cube divided by 48 EI, option B WA square B square divided by 3 EIL, option C is WA divided by B under root of 3 EIL and multiply is L square minus A square power 3 by 2, option D 5L cube divided by 384 EI, and option E is W under root of A cube B cube and divided by 48 EI. Correct answer is B. In the problem 227, deflection at C will be WA square B square divided by 3 EIL. Question number 230. The rate of change of bending moment is equal to option A shear force at that section, option B is deflection at that section, option C is a loading at that section, option D is a slope at that section, option E is a intensity of loading at that section. Correct answer is A, it will be shear force at that section. Question number 231. For a beam of uniform strength, if its depth is kept constant, then its width will vary in proportion to option A is bending moment capital M, option B is under root M, and option C is M square, and option D is 1 upon M, and option E is none of the above. Correct answer is A, it will be bending moment capital M. Question number 232. A beam is said to be uniform. A beam is said to be of uniform strength if option A bending moment is the same throughout the beam, option B shear stress is the same throughout the beam, option C is deflection is the same throughout the beam, option D is bending stress is the same at every section along its longitudinal axis, and option E is none of the above. Correct answer is D. It will be bending stress is the same at every section along its longitudinal axis. Question number 233. In a continuous curve of bending moment, the point of zero bending moment where it changes sign is called option A. The point of inflection, option B. The point of contraflexure, option C. The point of virtual hinge, option D is all of the above, and option E is none of the above. Correct answer is D. It will be all of the above. Question number 234. A reinforced cement concrete beam is said to be made of option A. Homogeneous material, option B. Heterogeneous material, option C. Isotropic material, option D all of the above, and option E is none of the above. Correct answer is B. It's called heterogeneous material. Question number 235. The steel bar in reinforced cement concrete beam are located at option A top, option B is bottom, option C is center, option D is the neutral axis, and option E is uniformly distributed. Correct answer is B. It's in bottom. Question number 236. When a rectangular beam is loaded longitudinally, shear develops on option A every horizontal plane, option B is every vertical plane, option C is a top fiber, option D is a bottom fiber, option E is a middle fiber. Correct answer is A. It will be every horizontal plane. Question number 237. If a beam of constant section is subjected throughout its length to a uniform bending moment, it will bend to option A circular arc, option B a parabolic arc, option C a catenary, and option D is elliptical shape, and option E is none of the above. Correct answer is A. It will be a circular arc. Question number 238. A shear force diagram for a cantilever beam carrying a uniformly distributed load over its length is option A is a triangle, option B is a rectangle, option C is a hyperbola, option D is a parabola, and option is a cubic parabola. So correct answer is A. It's a triangle. Question number 239. The rate of change of shear force at any section is equal to option A is a bending moment, option B is a loading, option C is a deflection, option D is a intensity of loading, and option E is a slope. Correct answer is D. It's a intensity of loading. Question number 240. The moment diagram for a cantilever beam whose free end is subjected to a bending moment will be option A is a triangle, option B is a rectangle, option C is a parabola, option D is a cubic parabola, and option E is a circular arc. So correct answer is B. It will be rectangle. Question number 241. Two beams have the same width, but one beam has double and depth of the other. The elastic strength of double depth beam compared to the other beam will be option A is double, option B is 4 times, option C is 6 times, and option D is 8 times, option E is none of the above. Correct answer is B. It will be 4 times. Question number 242. The ratio of deflection of two identical beams subjected to a central load W, but one fixed at both ends and the other supported freely, will be option A 1/2, option B is 1/3, option C is 1/4, option D is 1/8, and option E is 1/16. Correct answer is C, it will be 1/4. Question number 243. Two beams have the same depth, but one beam has double the width of the other. The elastic strength of double width beam compared to the other beam will be option A is the same, option B is half, option C is double, and option D is 1/4, and option E is none of the above. Correct answer is C, it will be double. Question number 244. Two beams have the same width and depth. The span of one is twice the span of other. The elastic strength of longer span beams compared to the other beam will be option A is the same, option B is half, option C is double, option D is 1/4, option E is none of the above. Correct answer is B, it will be half. Question number 245. The moment diagram for a cantilever beam carrying concentrated load at end of the beam will be option A is rectangle, option B is a triangle, option C is a parabola, option D is a cubic parabola, and option E is elliptical. So correct answer is B, it will be triangle. Question number 246. It's a beam of uniform strength so vary in section that the option is bending moment remain constant, option B is a deflection remains constant, and option C is a unit stress remains constant, option D is all of the above remain constant, option E is any one of the above remain constant. Correct answer C, it's a unit stress remains constant. Question number 247. For a cantilever beam of uniform width in a plane and loaded by a concentrated load at the end, the profile of the shape of the beam is elevation. In order that beam is of uniform strength should be option A uniform depth, option B is a triangular, option C is a parabola, option D is a cubic parabola, option E is none of the above. Correct answer C, it will be parabola. Question number 248. For a cantilever beam of a uniform depth in elevation and loaded by concentrated load at the end, the profile of the shape of the beam in plane in order that beam is of uniform strength should be option A uniform width, option B is a triangular, option C is a parabola, option D is cubic parabola, option E is none of the above. Correct answer B, it will be triangular. Question number 249. Point of contraflexure occur in option A simply supported beam, option B beam carrying load varying from 0 at one end and maximum at other, option C is cantilevers, option D is overhanging beams, and option E is any type of beam. Correct answer is D overhanging beams. Question number 250. The bending moment diagram will be a cubic parabola In the case of a cantilever, load as follows. Option A is a bending moment applied at free end. Option B, concentrated load at the end. Option C, uniformly distributed load. Option D, varying load 0 at free end and the maximum at fixed end. Option is a uniformly distributed load and the concentrated load at free end. Correct answer is D. It will be varying load 0 at free end and the maximum at the fixed end. Question number 251. The moment diagram for a cantilever beam carrying a linearly varying load from 0 at free end and 0 at free end to maximum at supported end will be. Option A is a rectangle. Option B is a triangle. Option C is a parabola. Option D is a cubic parabola. Option E is elliptical. Correct answer is D. It will be cubic parabola. Question number 252. In the case of cantilever, irrespective of the type of load, irrespective of the type of loading, the maximum bending moment and maximum shear force occur at. Option A is free end. Option B is under the load. Option C is a fixed end and option D is a middle and option E is any point. Correct answer is C. It will be fixed end. Question number 253. When a rectangular beam is loaded longitudinally, shear develop on. Option A, top fiber. Option B is middle fiber. Option C is the bottom fiber. Option D is every horizontal plane. Option E is a vertical fiber. Correct answer is D. It will be every horizontal plane. Question number 254. When shear force along a section is 0. Option A, bending moment is maximum or minimum. Option B, bending moment is 0. Option C is bending moment is in between maximum and minimum value. Option D is bending moment is infinity. Option E is bending moment is unpredictable. Correct answer is A. It will be maximum or minimum. Question number 255. When a rectangular beam is loaded transversely, the maximum compressive stress develops on. Option A is a bottom fiber. Option B is a top fiber. Option C is a neutral axis. Option D is a every cross section. Option E is a middle fiber. Correct answer is B. It's on top fiber. Question number 256. Coefficient of cubic expansion is. Option A, equal to the coefficient of linear expansion. Option B, twice the coefficient of linear expansion. Option C is twice the coefficient of superficial expansion. Option D is 1.5 times the coefficient of superficial expansion. Option E is 0.75 times of the coefficient of superficial expansion. Correct answer is D. It will be 1.5 times of the coefficient of superficial expansion. Question number 257. Hoop stress in thin walled cylinder is. Option A, compressive stress. Option B is radial stress. Option C is circumferential tensile stress and option D is a longitudinal stress and option E is a shear stress. Correct answer is C. It will be circumferential tensile stress. Question number 258. When a strip made of iron and copper is heated, option A, does not bend. Option B, it gets twisted and option C, it bends with iron on concave side, and option D, it bend with iron on convex side. Option E is none of the above. Correct answer C, it's a bend with iron on concave side. Question number 259. Modulus of resilience is option A, property of resist shocks. Option B, property of the property to store energy without undergoing permanent deformation. Option C, an index of elasticity. Option D is an index of compressibility. Option E is a property of withstand heavy pressure. Correct answer is B, it's a property to store energy without undergoing permanent deformation. Question number 260. During the tensile test of a glass rod, the nature of a stress strain curve is option A is straight and dropping. Option B is a sudden break. Option C is a straight line. Option D is parabolic. Option E is none of the above. Correct answer B, it's a sudden break. Question number 261. During impact loading, the stress developed as compared to gradually applied load is option A 1.5 times, option B 2 times, option C 2.5 times, option D is 3 times, and option E is 4 times. So correct answer is B, it will be 2 times. Question number 262. In a laminated spring, the strips are provided in different lengths for option A, equal distribution of stress. Option B, better look. Option C, light in weight. Option D, ease in installing, and option E is none of the above. So correct answer is A, it will be because of equal distribution of stress. Question number 263. Ratio of thickness to diameter for thin cylinder is option A 1/10, option B 1/15, option C 1/20, option D 1/40, option E 1/30. Correct answer is C, it will be 1/20. Question number 264. It is be assumed that the longitudinal strain is constant at any point in the thickness of the cylinder. Then radial stress SR and hoop stress SH are related as follows. Option A, SR minus SH is equal to constant. Option B, SR plus SH is equal to constant. Option C is SR upon SH is equal to constant. Option D, SR minus SH divided by SR is equal to constant. Option E is SR minus SH divided by SH is equal to constant. So correct answer is A, it will be SR minus SH is equal to constant. Question number 265. The hoop stress of a thick cylinder is considered at it is a maximum at option A near center, option B outer radius, option C is inner radius, option D is depends on the type of loading, option E is none of the above. Correct answer is C, it will be inner radius. Question number 266. It's a hoop stress in a thin cylinder of diameter D and thickness T subjected to pressure P will be? Option A is PD upon 4T, option B is PD upon T, option C is PD upon 2T, option D is 2PD upon T, and option E is 4PD upon T. Correct answer C, it will be PD upon 2T. Question number 267. In a thin cylinder, all along the thickness of the cylinder, option A, hoop stress and longitudinal stress are almost constant, option B, hoop stress and longitudinal stress are equal, option C, hoop stress is constant and longitudinal stress varies considerably, option D is a longitudinal stress is constant and hoop stress varies considerably, option E, both hoop stress and longitudinal stress varies considerably. Correct answer is A, it will be hoop stress and longitudinal stress are almost constant. Question number 268. In a thick cylinder, along the thickness of the cylinder, option A, hoop stress and longitudinal stress are almost constant, option B, hoop stress and longitudinal stress are equal, option C, hoop stress is constant and longitudinal stress varies considerably, option D, longitudinal stress is constant and hoop stress varies considerably, option E, both hoop and longitudinal stress varies considerably. Correct answer is E, it will be both hoop and longitudinal stress varies considerably. Question number 269. The stresses at any point in the thick cylinder are option A, tensile, option B is a compressive, option C is a shear, option D is a compound, option E is a principal. Correct answer is E, it will be principal. Question number 270. According to Lami's equation, hoop stress for a thick cylinder at any point at a radius r from center is equal to option A, B upon r square plus A, option B, B upon r square minus A, option C is B upon r plus A, option D is B upon r minus A, option E is B upon r cube plus A. Correct answer is A, it will be B upon r square plus A. Question number 271. In thick cylinders, the stress can be uniformly distributed over the thicknesses by the method of pre-stressing as follows, option A, self-hooping, option B, constructing laminated cylinders, option C, shrinking hollow cylinder over main cylinder, option D, any one of the above, and option E is none of the above. Correct answer is D is any one of the above. Question number 272. The longitudinal stress in a thick cylinder of diameter D, thickness T, and subjected to pressure P will be option A, PD upon 2T, option B, PD upon 4T, option C, PD upon T, and option D is 2PD upon T, and option E is none of the above. Correct answer is E, it's called none of the above. Question number 273. The radial pressure and hoop tension in a case of a thick cylinder is option A, maximum at inner surface and decreases towards outer surface, option B, minimum at inner surface and increases towards outer surface, option C, minimum at inner and outer surface and maximum in middle, option D, maximum at inner and outer surfaces and minimum in middle. Option E is none of the above. Correct answer is A, maximum at inner surface and decreases towards outer surface. Question number 274. Thin cylindrical shell of diameter d and thickness t is subjected to internal pressure P. Poisson's ratio of material is mu. The circumferential or hoop strain is option A, PD upon 2TE multiply 1 minus 2 mu. Option B, PD upon 4TE into 1 minus 2 mu. Option C is PD upon 2TE 1 minus 1 upon 2 minus mu, and option D, PD upon 4TE in the small bracket 1 upon 2 minus mu, and option E is PD upon 4TE in the small bracket 1 minus 1 upon 2 mu. Correct answer is A. It will be PD upon 2TE in the small bracket 1 minus 2 mu. Question number 275. In above case, the longitudinal strain is option A, PD upon 2T in the small bracket 1 minus 2 mu. Option B, PD upon 4T in the small bracket 1 minus 2 mu. Option C is PD upon 2T E in the small bracket 1 upon 2 minus mu, and option D is PD upon 4TE in the small bracket 1 upon 2 minus mu, and option E, PD upon 4TE in the small bracket 1 minus mu upon 2. So correct answer is D. It will be PD upon 4T in the small bracket 1 upon 2 minus mu. Question number 276. If the hoop strain and longitudinal strain in a case of a thin cylindrical shell are E subscript N and E subscript maybe L, then volumetric strain is equal to option A, En plus El, option B, 2En plus 2El, option C, En plus 2El, and option D, 2En minus El, and option E is 2El minus En. Correct answer is a B. It will be 2En plus 2El. Question number 277. The design of thin cylindrical shell is based on option A, hoop stress, option B, longitudinal stress, and option C is a volumetric stress, and option D, average of hoop and longitudinal stress, and option E is all of the above. Correct answer is A, based on hoop stress. Question number 278. Volumetric strain in a case of a cylindrical shell of diameter d and thickness t subjected to internal pressure P having coefficient of elasticity capital E and Poisson's ratios mu is equal to option A, PD upon TE in the small bracket 2 minus mu, option B, PD upon 2 TE in the small bracket 3 minus 2 mu, option C is a PD upon 3 TE in the small bracket 4 minus 3 mu, option D, PD upon 4 T in the small bracket 5 minus 4 mu, option E is PD upon 4 TE in the small bracket 4 minus 5 mu. Correct answer is D. It will be PD upon 4 TE in the small bracket 5 minus 4 mu. Okay. Question number 279. In above case, the ratio of longitudinal to volumetric strain is option A, 1 minus 2 mu divided by 5 minus 4 mu, option B, is a 2 minus mu divided by 5 minus 4 mu. Option C 1 minus 2 mu divided by 4 minus 5 mu. Option D 1 minus 2 mu divided by 3 minus 4 mu. Option E is 3 minus 4 mu divided by 1 minus 2 mu. So correct answer is A. It will be 1 minus 2 mu divided by 5 minus 4 mu. Question number 280. In above case, the ratio of longitudinal strain to hoop strain is option A 1 minus 2 mu divided by 2 minus mu. Option B 2 minus mu divided by 1 minus 2 mu. Option C is 1 minus 2 mu divided by 1 minus mu. Option D is 2 mu plus 1 divided by 1 minus 2 mu. Option E is 1 plus 2 mu and divided by 2 plus mu. So correct answer is A. It will be 1 minus 2 mu divided by 2 minus mu. Question number 281. Autofrettage is the method of option A calculating stress in thick cylinders. Option B relieving thick cylinders. Option C pre-stressing thick cylinders. Option D increasing life of thick cylinders. Option E joining thick cylinders. Correct answer is C. It's a pressing thick cylinders. Okay. Question number 282. Proof load for spring. Proof load for springs is the maximum load that it can undertake. Option A without producing permanent deformation in spring material. Option B up to elastic limit. Option C up to yield point. Option D to straighten fully the leaf of a carriage spring. Option E to satisfy the fatigue requirements. Correct answer is A. It will be without producing permanent deformation in spring material. Question number 283. If all the springs of a leaf spring are made of the same length, then it would result in option A uniform distribution of shearing force. Option B uniform deflection. Option C maximum capability of taking maximum bending moment. Option D is a uneconomical use of spring material, and option E is a spring of uniform strength. Correct answer is a D. It will be uneconomical use of spring material. Question number 284. A composite shaft consisting of a two-stepped portions having spring consist of K1 and K2 is held between two rigid supports at ends. Its equivalent spring constant is option A K1 plus K2 divided by 2. Option B K1 K2 divided by K1 plus K2. Option C K1 plus K2, and option D K1 plus K2 divided by K1 K2, and option E is none of the above. Correct answer is C. It will be K1 plus K2. Question number 285. A composite shaft consisting of a two-stepped portions having spring consist of spring constants of K1 and K2 is held firmly at one end and other end is free and subjected to a torque T. Its equivalent spring constant is option A K1 plus K2 divided by 2. Option B K1 K2 divided by K1 plus K2. Option C is K1 plus K2, and option D is K1 plus K2 divided by K1 K2, and option E is none of the above. Correct answer is B. It will be K1 K2 and divided by K1 plus K2. Question number 286. If a shaft of radius r and polar moment of inertia j be subjected to bending moment m and torque T, then maximum combined shear and bending stress is equal to option A R upon J in the under root m square plus T square, option B J upon R under root m square plus T square, option C 2R upon J under root m square plus T square, option D R upon J in the capital bracket m divided by 2 plus under root m square plus T square, and option E is R upon J under root m square plus T square divided by 2. Correct answer is A. It will be R upon J under root m square plus T square. Question number 287. A torsion bar with a spring constant K is cut into n equal lengths. What is the spring constant of each portion? Option A K upon n, option B n under root K, and option C K power n, option D n dot K, and option E is n power K. So correct answer is D. It will be n into K. Question number 288. Two identical springs of spring constant K in a series are attached in series with a parallel combination of two identical springs of spring constant K. The overall equivalent spring constant is option A 2.5 K, option B 1.25 K, option C is 0.4 K, option D is 0.8 K, option E is 0.2 K. Correct answer is a C. It will be is a 0.4 K. Question number 289. Two identical leaf springs of spring constant K are arranged like cantilevers in parallel and attached at a free end by a spring of spring constant K. The equivalent spring constant of combination is option A 2.5 K, option B 1.5 K, option C is 0.4 K, option D 0.75 K, option E is 3 K. Correct answer is B. It will be 1.5 K. Question number 290. An overhanging beam is option A same as cantilever, option B not same as cantilever, option C one which extends beyond its support at either end, option D one which extends beyond its support at both ends, and option E is none of the above. Correct answer C. Overhanging beam is the one which extends beyond its supports at either end. Question number 291. Neutral plane of a beam is option A is in the middle, option B passes through the center of gravity, option C is a one whose length remains unchanged during the deformation, and option D lies at bottommost fiber, and option E is none of the above. Correct answer is a C. It's the one whose length remains unchanged during the deformation. Question number 292. Section modulus is defined as option A is W K square divided by GY, option B P upon delta V upon V, and option C MI divided by Y, and option D is sigma Y delta A, and option E is MI upon Y square. Correct answer is a C. It will be MI divided by Y. Question number 293. If the thickness and width of each plate of a laminated spring be T and W respectively, then its moment of inertia is equal to option A Wt cube divided by 12, option B Tw cube divided by 12, option C Wt square divided by 12, option D Tw square divided by 12, and option E is Wt power 4 divided by 12. Correct answer is A, it will be Wt cube divided by 12. Question number 294. The load taken by a laminated spring to make it flat is called option A ultimate load, option B proof load, option C is bending load, option D is maximum safe load, option E is yielding load. Correct answer is B, it will be proof load. Question number 295. Beam of uniform strength can be obtained by option A keeping depth constant throughout the length and varying the width suitably, option B keeping the width constant throughout the length and varying the depth suitably, option C varying both the depth and width suitably, and option D is any one of the above, and option E is none of the above. Correct answer is D, it will be any one of the above. Question number 296. When a beam is loaded, the horizontal or longitudinal shear should be accounted for materials like option A mild steel, option B is a concrete, option C is cast iron, option D is a wood, option E is lead. Correct answer is D, it will be wood. Question number 297. According to Hooke's law, stress and strain, option A are directly proportional, option B are inversely proportional, option C are curvy linearly related, option D are unpredictable relationship, option E is none of the above. Correct answer is A, are directly proportional. Question number 298. Radius of curvature of a stretched beam and modulus of elasticity, option A are directly proportional, option B are inversely proportional, option C are curvy linearly related, option D have unpredictable relationship, option E is none of the above. Correct answer is D, they have unpredictable relationship. Question number 299. Stress in a beam and the second modulus, option A are directly proportional, option B are inversely proportional, option C are curvy linearly related, option D have unpredictable relationship, option E is none of the above. Correct answer is B, are inversely proportional. Question number 300. Stress in a beam and moment. Stress in a beam and moment, option A are directly proportional, option B are inversely proportional, option C have curvy linearly related, option D have unpredictable relationship, option E is none of the above. Correct answer is A, are directly proportional.